Hey, what's up, guys? It's Robert Yang. Um, in today's video, I'm going to talk to you guys about PLC. PLC stands for Program Logic Controller. I want to talk to you guys about PLCs because I worked in a manufacturing company for 20 years, and PLC plays a big role in understanding on how automation machinery and how the equipment works and how the machine starts and stops and how the whole system works. So PLC controls all that, the whole system. Like I said, PLC stands for Program Logic Controller. PLC uses a program called ladder logic programming. This means that the program is read like how a person reads a book from top to bottom, left to right. PLC is designed with simple language to control programs. So both of these things makes it easier for engineers, programmers, and operators to understand how the program is written out. They want to change the program, they want to rewrite a new program, or if something's wrong with the program, they can go right in to fix it. So a lot of other programmers uses like weird codes or it's all over the place, so it's harder to understand. But PLC uses a simple programming, so it makes it easier for the programmers or people to understand. It's a unique form of microprocessor-based controller that uses a programmable memory and saves instructions and executes functions such as logic, sequencing, timing, counting. PLC offers flexibility and it's cost effective by reducing the complex electromagnetic relay circuits before automation. So a little bit history about PLC is industrial automation began long before PLCs was created. Um, the process before PLCs was created was usually done by using complex relay circuits, relays, wirings, and it needed a lot of space to be able to do this. So, according to a beginner's PLC overview, in 1968, the first program logic controller was created to replace these circuits in industrial plants. In 1970s, PLC manufacturers began creating program devices which allowed PLCs to be digitally programmed. In 1980s, a third-party software that was created was compatible with PLCs, which became available to reducing the cost of PLCs. During the 1980s, IEC standard for program controllers was established, which ensured that PLC programs were held up to various standards and created a uniformity among PLC software. This was very beneficial because it made the programmers easier to understand. Today, the PLC still have the same core functions and simplicity that made it so popular in manufacturing places. However, with continued progress, PLCs are becoming even smaller and even more have the ability for power and speed. So how does PLC work? PLCs are basically a small computer that's used to automate or control process. One PLC can be used to control a wide range of control systems or like a whole system of machinery one PLC can use to control them. PLCs has many parts, but then they're categorized into three different groups, which is the processor, which is like the motherboard or the memory, and then the inputs and outputs. Basically, a PLC takes its inputs, which is the program that tells the machine to turn on, and then when the machine turns on, it sends an output back to the computer saying that the machine is on. So, for example, if you have a PLC in your household, which nobody's going to have that, it's usually for companies or system that you want to control. So, for example, you have a pool in your backyard and you want to turn the pump on for your pool, but you turn it on and you don't know if the pump is actually running, so you don't want to go out there to see if the pump is running. You have an automated system, so You will turn it on, and if the pump is running, it'll send a signal back to you saying that the pump is running. So that's a simple way of how PLCs work, and a simple way of how to explain it to you guys. The security for a PLC is a big there's a big downside to PLC and security. PLCs weren't created with security measures such as encryption or identification verification, so this makes it very easy to hack. One example of this is Stuxnet. Stuxnet showed that malware could be modified by an automation process by affecting systems with its ISC, overriding process logic controller, and hiding its activity from monitoring systems. So when Stuxnet happened, it showed a lot of people that PLCs is really easy to be hacked. So in conclusion, PLC is something very important for you to want to get to know if you want to get into manufacturing business and or understand it. It's understanding how PLC work will be very benefit for you. If you want to, PLCs can you can create, if you're into security, you can create a security system for PLC, and probably get you rich one day, because PLC has no security measures. So that concludes my thing about PLCs. Looking forward to seeing you guys' videos too, and thanks for watching.